In this video, there are 4 reactions we want to show you that all come under the heading of a clock reaction. The first 2 are one-offs in that there is an end point which is fairly obvious. In the last 2, they are oscillating clock reactions which change backwards and forwards. The chemistry for all these reactions is fairly complex, so this will be a light touch treatment. What can be said about each reaction is that they all involve at least one slow reaction, followed by a very fast reaction which produces a color change. In the first step, hydrogen peroxide solution reacts with the iodide solution in a slow reaction. This produces the I3- ion. The I3- ion in turn reacts very rapidly with the thiosulfate solution, using it all up. When the thiosulfate solution is used up, the I3- ion is free to react with starch to form the traditional blue-black complex. It's actually the I3- ion rather than iodine that forms this coloration. But the I3- ion is formed when iodide, I-, chemically joins with the I2, the iodine molecule. In the second reaction, the old Nassau Clock reaction, which is also called by some the Halloween reaction, we have a variation of the iodine clock. Now the chemistry here is slightly more complicated because there's a 2-stage color change caused by the reaction of mercury ions with iodide ions, producing the yellow coloration. The blue-black scenario is produced when the iodide ion produces sufficient iodine to then react again with some more iodide ion, forming the I3- ion in the presence of starch. So then forms the blue-black starch-iodine complex. To understand why you can get a yellow coloration of mercury iodide, you need to have an understanding of the solubility product, which I'm not going to go into here. The third reaction is the first of the 2 oscillating clock reactions. The first is usually given the name of the BZ reaction, Belousov-Zhabotinsky reaction. I've only given the overall equation for the reaction here because, depending on which text you look up, this is the result of 14 chemical reactions all going on at the same time. It's very complex, but all that you need to know here is that the orange coloration is due to free bromine. The bromine is produced in one set of reactions and is used up in another set of reactions, hence the oscillation. The last reaction is a variation on the BZ reaction. Here we have orange coloration due to free iodine, and the blue coloration yet again due to the starch-iodine complex.